A coupling reaction in organic chemistry is a general term for a variety of reactions where two hydrocarbon fragments are coupled with the aid of a metal catalyst. Now, we talk about several coupling reactions include not exhaustive, Wurtz reaction, Glaser coupling, Ullmann reaction, Grignard reaction, Heck reaction, Sonogashira coupling, Stille reaction and Suzuki reaction. The Wurtz coupling is one of the oldest organic reactions. It is an organic reaction used to couple two alcoholides to form an alkene using sodium metal. The halogen element includes chlorine atom, bromine atom and iodine atom. The intramolecular version of the reaction has also found application in the preparation of strained ring compounds. The mechanism begins with a single electron transfer from sodium metal to the alkyl halide, which dissociates to form an alkyl radical and sodium halide salt. Another molecule of sodium performs another single electron transfer to the alkyl radical to form a nucleophilic carbanion. The carbanion then attacks another molecule of alkyl halide in a nucleophilic substitution reaction to form the final coupled product, and another molecule of sodium halide salt. The Glaser coupling is a synthesis of symmetric or cyclic bisoacetylenes via a coupling reaction of terminal alkynes. Mechanistically, the reaction is similar to the Eglinton reaction, the difference being the use of catalytic copper I, which is reoxidized in the catalytic cycle by oxygen in the reaction medium. The Eglinton reaction has been used to synthesize a number of fungal antibiotics, and is important for carbon-carbon bond formation via the oxidative coupling of alkynes. The Ullmann reaction is an organic reaction used to couple two molecules of aryl halide to form a biaryl using copper metal and thermal conditions. The mechanism for the Ullmann reaction is not fully understood, but there are two popular mechanisms. The radical mechanism begins with a single electron transfer from the copper metal to the alkyl halide to form an aryl radical. Two aryl radical then react to form the final biaryl product. The second proposed mechanism begins with oxidative addition of the copper to the aryl halide, followed by a set to form an organocuprate reagent. The organocuprate performs another oxidative addition on an aryl halide, and after reductive elimination results in the final biaryl product. The Grignard reaction is an organometallic chemical reaction in which alkyl, vinyl, or aryl magnesium halides add to a carbonyl group in an aldehyde or ketone. This reaction is an important tool for the formation of carbon-carbon bonds. The Grignard reagent is formed through the reaction of an alkyl or aryl halide with magnesium metal via a radical mechanism. The mechanism of the subsequent reaction of the Grignard reagent with the electrophile is debatable. The most popular proposals are a concerted mechanism or another radical mechanism. Both can explain the final addition product. The Heck reaction is the chemical reaction of an unsaturated halide with an alkene in the presence of a base and a palladium catalyst to form a substituted alkene. The reaction begins by oxidative addition of the aryl halide to the palladium, which is followed by coordination and migratory insertion of the olefin to the palladium. Bond rotation then places the two groups trans to each other to relieve the steric strain, and subsequent beta hydride elimination results in a trans final product. Base-mediated reductive elimination regenerates the palladium catalyst. The Sonogashira cross-coupling reaction is the organic reaction of an organohalide with a terminal alkyne to give the coupled product using a palladium catalyst, a copper catalyst, and base. This reaction's applications include pharmaceuticals, natural products, organic materials, and nanomaterials. The palladium-catalyzed mechanism begins with oxidative addition of the organohalide to the PD to form a PD complex. Transmetallation with the organocopper reagent, formed from the terminal alkyne, and the copper catalyst, then follows. The alkynyl anion replaces the halide on the palladium complex, and regenerates the copper halide catalyst. Reductive elimination then gives the final coupled product, regenerates the palladium catalyst, and the catalytic cycle can begin again. The Stille reaction, or the Maijita-Kosugi-Stille coupling, is the organic reaction of an organohalide with an organose-tannin compound to give the coupled product using a palladium catalyst. The mechanism begins with oxidative addition of the organohalide to the PD to form a PD complex. Transmetallation with the organose-tannin then follows, where the R group of the organose-tannin reagent replaces the halide anion on the palladium complex. Reductive elimination then gives the final coupled product, regenerates the palladium catalyst, and the catalytic cycle can begin again. The Suzuki reaction is an organic reaction, classified as a coupling reaction, where the coupling partners are a boronic acid and an organohalide catalyzed by a palladium complex. The mechanism begins with oxidative addition of the organohalide to the PD to form a PD complex. A molecule of the hydroxide or alkoxide base then replaces the halide on the palladium complex, while another adds to the organoboron to form a borate reagent, making its R group more nucleophilic. Transmetallation with the borate then follows, where its R group replaces the halide anion on the palladium complex. Reductive elimination then gives the final coupled product, regenerates the palladium catalyst, and the catalytic cycle can begin again.